Okay. Now, my questions I gave you and the ones I have are now a little bit different because, as you can see in your worksheet, unless you have the new one. No. Let me see your one. Oh, you do have the new one. I printed it for you. This one here. Yeah, because the one I gave you originally, I did the first one in class. Okay, let's have a look. So, in question 1, in the circuit below, each cell provides a potential difference of 6 volts. Perhaps should really say it, EMF. The resistance in the 3 resistors are 2, 3, and 4. So this is a 2. This is a 3. This is a 4. And this together is a 12. Okay, let's, what am I looking for? What is the voltage and the currents, basically? Okay, so we'll call this one here I1. So this one here will be I2, and this one here will be I3. So the junction rule here says I1 minus I2 minus I3 equals 0. So that's equation 1. We can make a loop, so I can make a lower loop. I can say, we'll call that A, equation A. So I can say 12 minus 2I1 minus 4I3 equals 0. So I can say 6 minus I1 minus 2I3 equals 0. So I can say I1 plus 2I3 equals 6. That's B. And C is very similar because I can do nearly the same thing. I can say 12 minus 2I1 minus 3I2 equals 0. So I can say 2I1 plus 3I2 equals 12. Okay? Right. So, let's have a look here. What would be the best way to put these together? I could cancel the I1s, couldn't I? Because I could make this a 2. This would be a 4. Actually, I'm kind of going backwards. And that would be a 12. And that would be a 2. That would be a 2. And that would be a 2. So, minusing these two, I'll get minus 2I2 minus 6I3 equals minus 12. And minusing these two, I'll get minus 3I2 plus 4I3 equals 0. By the way, fun fact, this is the equation you get if you were to loop around this small loop. Question, Monica? Which one? Well, I did A minus B and B minus C. Minus A minus C. That's fine. Oh yeah. It doesn't matter which way you pair them off. Okay, multiply this by 3 and this by 2, and now these become minus 6I2 minus 18I3 equals minus 36, and then here this becomes minus 6I2 plus 8I3 equals 0. Minus in again, minus 18 minus 8, what's that? Minus 26, is it? Is that right? Minus 26? I tray equals minus 36. So I have my I tray, 36 over 26, that's 18 over 13 amps, whatever that is. And I can get my I2, and I can get my I1. So I'll get my I2 here. What's this as a decimal, please, Monica? This I3? 1.385 amps. Okay. And now I2 would be 4/3 of this. Can you multiply this by 4 and divide it by 3? 1.85 amps. Okay, that's I2. And I1 will be I2 plus I3. So adding these two together. So what's that? 3.23 amps then. Okay, so there are the three currents. Now, if I look back here, you can say V equals I or. So by using that, I can get V1 is 2 times this, V2 is 3 times this, and V3 is 4 times this. So V1 would be 6.46 volts. Multiplying this by 3, 5.55 volts, and multiplying this by 4, 5.54 volts. Yeah. Now the good news is you can check if this is right, because, well, there's a small rounding error, because really V2 and V3 should be the same, because if you look at the picture they're in parallel. So which one do we think is a bit more accurate? Well, we can go back to this, because they both should add together to make 12. So I feel like I should probably just fix this up and make it a 4. Because then these two together will make exactly 12, and then these two will be equal. So, yeah. So this is a nice little Kirchhoff question. If you didn't get this, can you write this down? Can I have a spare pencil again? Now, can I keep this for today? Is okay? Or do you need it? You got another one?
I only have one pencil.
Oh, that's so sad. Someone else can give me something. I can use a pen. Anything. Anything. Thank you. Well, look who made it in. Okay. You don't need to write this down. You got it right. Okay. Can we go on to number 2 now? Yeah. Is it though? Can I see your picture? Yeah, it is the same. And it's hard, you say. Let's find out. Okay, so there's a resistor. There's a cell, there's a cell, there's a resistor, there's a resistor. Now let's see what info we know. These are both 1 ohms, so that's helpful. This big guy here, he's a 10. And we basically, the question is, what is the voltage here? We want to know what's if you stick a voltmeter around Mr. 10 here, how much voltage will he be consuming? And these batteries, this battery, the 2 cells, 6 and a 12. 6 and a 12 volt. Okay, so let's draw in our currents. This we can call I1. This we can call I2. Well, that's pointing the wrong way. It's going to the left. So that way is I1. That way is I2. That way is I3. Okay. So it's actually interesting because this is like what I said we will look at later. What happens when the cells are parallel? For example, if these were in series, the problem would be a lot easier because, well, I know there's resistors here, but basically this could be like 18 volts. So the question is, what happens when we have them in parallel and these small resistors here? So let's see. Kirchhoff says I1 plus I2 minus I3 equals 0. We can make a loop on the inside. We can say 6 minus 10I3 minus, and here that's I1 equals 0. And I would make one more loop. I could make another big loop, but I really care about finding I3. So to find I3, I need to cancel I1 and I2. So to cancel I1 and I2, I need to have I1 in everything and I2 in everything. So I feel like it would be quickest if I do a small loop here. Starting at the 12, I can say 12 minus 6 plus I1 minus I2 equals 0 by looping around this way. Okay? Yeah? Is that okay, guys? You look quiet and shocked. It's okay? Alright. So let's see. I can say I1 plus I2 minus I3 equals 0. I1 plus 10I3 equals 6. And I1 minus I2 equals minus 6. 12 minus 6 is 6. Minus 6 then. Okay, let's cancel I1 and cancel I1. So I2 minus I2, no I2 is I2, minus 11 I3 equals minus 6. I2 plus 10 I3 equals 12. Now, remember I said I'm looking for I3, so I'll just cancel I2s. Nice. That is minus 21 I3 equals minus 18. So I3 equals 18 over 21. But we want V, which is I or. So V3 will be 10 times 18 over 21, which is 180 over 21. Which is what's that, about 8, is it? 8.57 volts then, is what the voltmeter would say. Question, Monica?
Yes.
Go on.
Because you have 6 volts and you have 1 volt, you have 12 volts and you have 1 ohm. Can't you get I1 and I2 like that?
Oh, you're saying that
Like the top 5.
this should be twice as big as this. Is that what you're saying?
But you can get the current.
Don't use the word guess. You can
Yes,
infer.
yes.
Oh, get.
Yes, you can get the current to have voltage and resistance. What's the...
Oh, I see what you mean. You can just simply say here. Although, technically speaking, we don't know the voltage really. Like, we know that there is a cell in there providing 6 volts, but there's other stuff happening in the circuit. Do you know what I mean?
What's the effect of the 12 being in parallel?
Like, for example, this is 6 and this is 12, and you're suggesting we use the 6 and the 12 to get the I1 and I2. But we know automatically that these voltages across the I1 and the I2 are the same because they're in parallel. Do you get what I'm saying? If you have 2 wires here and here, and let's say there's something else going on here and here, doesn't really matter what's going on. If they're in parallel, then the voltage across the top is the same as the voltage across the bottom. So in fact, I don't think it'll be 6 or 12, it'll be something in between perhaps. So we don't actually know what the voltages are on the top and the bottom level. Yeah?
So what's the effect of the cells being in parallel?
It's not clear because we've arrived at some answer that's in between the 6 and the 12, but it's not exactly in between. It's not like it's the middle of the 6 and the 12. So the point I was making when I said it earlier was it's complicated, and we'll do it later. It's complicated because there is no simple apparent rule to make the 8.57. If the answer was something like 9, if the answer was 9 volts, then I'd say, so you can see that the parallel cells, the voltage combines and it's exactly in the middle, but it's not that. I mean, it's nearly 9, but it's not quite. I have a feeling that if I was to make this bigger and these two smaller, this would get closer to 9, but without recalculating I wouldn't know. Okay, that was a harder one then, was it? Did anybody get the 8.57? Is that a yes or a no? Okay, can we go to the last one now? Yeah. Okay, now that I've done 2 examples of these, I will do the third one, but I want to show you how you can do this on the calculator, because it would be useful to check your answer in the exam. And if you were to actually look at question 3 really carefully, you'll actually realize that question 3 is the same circuit, although different numbers, the same circuit as question 2. In question 3, the OR2 and the OR3 are like the OR1 and the OR2 in the previous question. The E1 and the E2 are the same, although there is one big difference in circuit 3 to circuit 2. What would that be? Well, if you look at E2, it's the backwards. Yeah. Okay, so to finish this, I'd like practice one more time making the equations. So I'll go with Jerry first. Jerry, give me a Kirchhoff equation. I2 plus I3 minus I1 equals 0. Okay. I2 plus I3 minus I1 equals 0. Or in other words, I1, if I take this to the right, I1, so 1 I1 minus 1 I2 minus 1 I3 equals 0. So these numbers I care about. 1 minus 1 minus 1, 0. Okay. Chew! Give me another equation. Where do you want to start? E1 is 3 volts. Okay, so start with 3. 3 minus
E2.
Oh, you're going down. Okay. No. Go down. That's good. 3. I think this will be plus E2, which is a 4, because you're going into it. And then you get to the next one.
Minus R3.
Ah, they tricked you. It's a plus. Why is it a plus? Plus I3 times R3, which is 300.
Oh.
Why is it a plus?
Why is it plus?
Yes, that's what I'm asking you, Sean. Why is it a plus? Why is it a plus here, guys?
Because
Yes? No. Now, why is the 300 a plus?
the direct.
Yeah, you see here, too, we are going this way in it, and the current is going the other way, so it's the other side. And then lastly, on the top, minus I2 times 200. Minus 200 I2 equals 0. So we get 0 I1 minus 200 I2 plus 300 I3 equals minus 7. Yeah? Now, we need the 0, we'll need the minus 200, the 300 and the minus 7. Okay, Monica, give me one more equation here. Yeah. 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 So here you have 100 I1 plus 200 I2 plus 0 I3 equals 3. So you have 100, 200, 0 and 3. The reason I'm circling these numbers is because you can actually solve this on your calculator if you have this one by going mode 52. So on the top we have 1, minus 1, minus 1, 0. Yeah. Next we have 0, minus 200, 300, minus 7. And on the last one we have 100, 200, 0, 3. And so we get our answers nicely, eventually. 1 over, so that's milli, isn't it? If I multiply that by, divide by 10, 90.9 milliamps. I2, no, I did that wrong, didn't I? Multiply by 10, divide by 10. I'll need to make it, what you call it, micro. Divide this by 100, multiply this by 100. 909 microamps, that's I1. I2, is bigger. What's that now? Is that 14.5 milliamps? And I3, now that is minus 13.6 milliamps. Now that's interesting. Why is the last one minus? That's not a mistake. It is minus. Yeah, if you look at the picture, the I3 is actually drawn the wrong way. The current is actually flowing upwards, not downwards. That's what the minus is telling me here. Yeah.
Stephen, can you explain one more about like the flow?
What do you mean?
The back flow, like
with the resistor?
no, in like E1 and E2.
Yeah.
And R3.
Yeah. Oh, sorry. Do you have this, Chu? So look. If you're walking around the loop this way, you get an increase. So you do a plus, because you're going into the cell and it's like the cell is giving you a boost. If you're walking this way, you're going against the cell, you have to give it energy, nearly.
Like,
so that's a minus.
So here is plus and there backward. So
I
minus.
suppose so, yeah. If this is the resistor, and you're walking through it this way, and the current is flowing through it the same way as you, then it means you will see the voltage decrease, because you're traveling in a direction with the current which is losing energy as it goes through the resistor. If you travel this way through it, you're traveling through it backwards. So it's almost like you're watching this happen backwards. So as you're traveling through it, you will see a gain instead of a loss if you're traveling through the resistor the wrong way. It's a bit confusing at first, I know this, but once once you remember these two facts, then that's all there is to it, really. Anything else?
Teacher, how the current move in the picture? Because E2 has no current coming out.
Doesn't?
Yeah, only I3 going into it, but what about the current?
Oh, but you see, I3 is pointing the wrong way in the picture. Because we got a minus I3, it actually is coming out, because our arrow's pointing the wrong way.
Okay, then E2 is going in E1, but what it goes out is I1.
What goes out of E1 is I1, correct. No, what goes out of E1 is I2.
Yeah, how about E1? Where does E1 come from? I2 plus I3.
Where does what come from? Which one? E1?
I1.
I1. Oh, I1 comes from, yes, I2 minus I3, really. The arrow's pointing the wrong way. Although if we forget about this answer and just look at the picture, yes, I1 will be I2 plus I3. Because on the left side here, the I2 and I3 combine to head back up. Huh? Yeah, if the I3 goes down.
I mean E2, the current of E2 goes to the right? And the current from E1 goes to the left. How do they meet?
Well, if they're going the wrong way, that's fine. It's just there'll be a minus instead of a plus. Okay, so what is ultimately your question? What is
just the flow of the current?
What are you unhappy about? Which one?
The whole picture.
Oh. I'm going to tell you something which may shock you, or may even horrify you, but such thinking is not helpful here. You really, really need to think of Kirchhoff as a maths problem. The moment you start thinking about, wait, hang on, is the current going the right way? Maybe it's going backwards. Maybe it needs to be a minus. Maybe it needs to be a plus. Who am I? What am I doing? It will just lead you down to a path of despair and craziness. Even though we totally drew the current the wrong way, I3, it's totally wrong, and we got a negative answer, that's acceptable. It simply tells me that the current from I3 is going the other way in the diagram. Now, if you start thinking deeply about that, it might start becoming quite confusing. But just so you know, it is possible to push the current through the cell the wrong way. So if you have a cell and a current is trying to come out, you are able to push through and force the current out the back end. The result of doing this is to make the cell behave like a resistor. So then it becomes more like a resistor than a cell, you know. I like to think of Kirchhoff as simply math problems. That's why I like them, because you just write the equations and you get the answers. You know. What do you mean? To get I2, I use the calculator here. The reason. No, I exclusively used the calculator to solve this. I wanted to show you how to use the calculator to solve this. So in the exam you can actually check your answers and make sure you have full marks. Yeah. Can I close this now?